Hey everyone, and welcome. Today we're going to dive into a really cool piece of tech that turns something we'd normally just toss out into something incredibly useful. We're talking about friction spinning, a process that is all about turning waste into wonder.
I mean, it sounds kind of like magic, right? How exactly do you take waste fibers, the leftovers, the scraps, and spin them into yarn you can actually use? This is a huge challenge in the textile world, especially in a country like India, which is not only a massive textile hub, but also has this amazing spirit of resourceful innovation. Well, the answer, as it turns out, lies in a pretty clever process.
Okay, so most of us have a basic idea of how spinning works. You probably picture a traditional spinning wheel, twisting fibers together into one long thread. But, there are other more specialized methods out there, and they're designed for very specific jobs. Friction spinning is one of those.
So, what exactly is it?
Well, to put it simply, instead of using a classic spindle to do the twisting, friction spinning uses, well, friction. Just imagine fibers getting caught between two surfaces that are spinning really fast. That rubbing force is what twists them together and creates the yarn. It's a totally different way of thinking about it. The easiest way to get your head around this is to think about rolling a small piece of cotton fluff between the palms of your hands. As you roll it back and forth, the friction from your hands twists those loose fibers into a rough little thread. Friction spinning is basically a super fast, industrial-sized version of that exact same idea. Okay, let's walk through it. So first up, a stream of loose fibers gets fed into the machine. Then you have these high-speed drums that start spinning against each other. As the fibers pass through, they get snagged by that spinning motion, and the friction just instantly twists them up. And the result? A brand new yarn shoots out the other side. It's formed in the blink of an eye. It's all about speed and simple mechanics. Right, so because the process itself is so different, the yarn it makes is also, well, really different. It's definitely not your typical super smooth, strong thread. It has its own unique set of characteristics, and that comes with some very specific pros and cons. And this is where we get to the really interesting trade-off. With friction spinning, you're giving up some things, like strength and uniformity. The yarn just isn't as strong as one that's traditionally spun, but in return, look what you get. High bulk, fantastic insulation, and a really low production cost. You're basically swapping perfection for something that's just incredibly practical. Okay, so the key here is really getting the why behind all this. Why is it weaker? Well, it's because the fibers are just loosely twisted together by friction. They're not tightly locked in. But that exact same loose, bulky structure, it's amazing at trapping air, which is exactly what makes it such a good insulator. The way it's made is what gives it these unique properties. All right, so we've covered the how and the what. But this is where friction spinning goes from just being an interesting process to something that's a real game changer. And it's all about the stuff you can feed into the machine. And this quote just nails the core benefit. The process isn't picky at all. It, quote, allows for the incorporation of a wide variety of fibers, including waste fibers. Think about that for a second. Waste fibers. Yeah, this is a huge deal. For a textile giant like India, a technology like this is, well, it's transformative. It means mills, say, in places like Tirupur or Ludhiana, can take all those scraps and short fibers, materials that would otherwise just be thrown out, and turn them into valuable products. It's the ultimate form of industrial recycling. It just makes sense for sustainability and for the economy. It's smart business and good for the planet, all rolled into one. Okay, so if this yarn is bulky and not super strong, what do you actually use it for? You're not going to make a fancy shirt out of it, right? Its job is way more industrial, way more practical, and it fills some very specific needs. This yarn is a total workhorse for stuff like technical textiles, things like industrial filters or cleaning cloths. It's perfect for insulation materials in buildings or appliances because of how well it traps air.
So basically, anywhere you need bulk, you need insulation, and you need it to be cheap, this is your go-to yarn. And honestly, that just sums it up perfectly. This is a technology where function absolutely wins out over finesse. It's not trying to be a beautiful, delicate thread. It's designed to be a cost-effective, practical material that gets a specific job done, especially when that job is turning trash into something useful.
It really makes you think, doesn't it? We're often chasing perfection in technology, but sometimes the most powerful innovations are the ones that are a little rough around the edges, the practical, affordable ones that make the most of what we already have. It's a mindset of resourcefulness you see all over the world. So it leaves you with a question. What other imperfect technologies might be out there, just waiting to help us build a more resourceful and sustainable future?